Hello, physics. I hope you are having a good 2 days before Thanksgiving break. This is just a quick reminder that you will have a quiz on Thursday about force diagrams. So hopefully you are on it. Now, the lab. We're going to call this lab P.4.2, and we're going to call this force of gravity. And so we've talked thus far about trying to draw qualitative representations of forces. And those qualitative representations of forces consisted of system schema and force diagrams. Now that we have a solid understanding of force diagrams and qualitative, now we're going to get started in the quantitative. And before we do anything in the quantitative, we have to look at the most fundamental force that is talked about in every single force diagram, and that is the force of gravity. And so we're going to actually measure the force of gravity. And the way we're going to do that is we've got our force sensors, and so you'll see this is called the dual range force sensor. I'm going to grab it out of the box like such, and it looks like this. Now, cord wrapped around it. Now you may have a different end on it. All you have to do is unscrew the end. If like you have a bumper end on it, all you need to do is just unscrew that bumper, and then you can grab this. But we need the hook on there, so the hook just screws right in like so. So that's the dual range force sensor. Now it has an end like this, which will not plug into your computer, but we do have Go links, and so you're going to need to grab a Go link like so. You will plug it into the Go link, and then the Go link has a USB port, and so then I can plug my USB port into my computer. Now I'm using this handy dandy mini computer here, my LabQuest, and I can plug it in, and it should read forces in newtons, and so it's starting to read some kind of forces. And so you can see that if I push on it, it's going to read a force, and if I pull on it, it's also going to read a force like so. So that's the reading of the force. What we're going to do with it is measure the force of gravity. And the way we're going to do that is we are going to just simply suspend objects. And so for instance, everyone will have a hook like this. That hook, you can just simply suspend from that guy, just like that. And so then I can measure the force of gravity. And the reason so what this force sensor is actually measuring is how much this is being pulled down. And so it's pulling it down. This weight is pulling it down by the same amount that this guy has a force of gravity acting down. And so therefore, this is showing me, this is going to tell me the force of gravity of this object. So I've got the force of gravity of this object. Well, I can change my weight or my force of gravity of this object by simply putting more weights on the hook. And so I have it like that, and then my force of gravity is going to change, and then I can simply put another weight on there like so. Okay, so that's how we can measure the force. All right, now we're going to measure the force like that. Make sure you're holding it as steady as possible. You don't want to be up and down in it because you're going to get force readings. You don't want that. You just want it motionless so that we have balance of forces. So that's how we can determine the force of gravity. The other thing that you're going to need to do is then grab the mass of the object. And so that's where I've got scales, and I will have them clearly labeled as to where they are, but I just grab my scale, I stick it on there. Now some of these guys say certain masses. Make sure it's set on grams. Yeah, there we go. Some of these say certain masses, like this says a mass of 50. Make sure that it is actually the mass that you say it is. Same with these smaller weights, because there's a little bit of, it's kind of has some wear and tear on it. So make sure it just says the mass that it actually is. Like this one says it's 500 grams, but it actually looks like it's more 510. So anyways, what you're going to do once you have all that, you're going to have the force, you're going to have a table. You're going to need to make a table. On that table, you're going to have the force of gravity on one, and then you're going to have the mass on the other. And so what we're going to do is we're going to design this experiment in a way that we are changing the mass and measuring the result in the force of gravity. So therefore, force of gravity will be our dependent variable. So once you have that data table, then you're going to create a graph with it. And you're going to linearize it if necessary, so you may have to look back in your notes if you need to linearize it. But you're going to get your data, plot it, and then you're going to write an equation for that line. And then you're going to have all that equation in your lab report. So what you're going to need to do for this, you're going to type a lab report, and here's what it should be in this brief lab report. It's not like a major thing. Title, lab, P.4.2, force of gravity. Purpose, to determine the equation to measure the force of gravity. That's what your purpose is going to read. To determine how we can mathematically determine the force of gravity. For your procedure, you don't even need to include one. Just include data, include that data table that I talked about, and the graph that you get. Discussion, I want you to include the written equation, the interpretation of the slope, the interpretation of the y-intercept, and then the final question that I want you to answer is this. How does the slope compare to a number that we've looked at in previous units? It's kind of difficult for me to word that question without giving away what we're talking about, but the question is, how does the number that we get for the slope compare to a number that we get in previous units? That's what we're trying to think. Now, if you don't get a value that's close to anything from a previous unit, then say, nothing. But if you get something remotely close to some constant that we've been dealing with over and over again, make note of that. And then conclusions we'll wait and write after the break. Okay? Now, that is for today. For tomorrow, we'll have something else planned.